This video is on Chapter 12, Part 2 on parallelograms. So we'll be investigating some of the properties of parallelograms in this video. You can go to this website for the applets that will be used subsequently. So first up, we have the sides of a parallelogram. So over here, we can drag the slider to the right, to investigate what is the relationship between opposite sides of a parallelogram. So as we slide, we see that the bottom line segment of the parallelogram, the bottom side of the parallelogram, is being moved upwards, and we see that opposite sides are parallel to each other and they have the same length. So likewise, for the other side, we slide it over, they remain parallel and they have the same length. So let's go ahead and fill in the blanks. Opposite sides are parallel to each other, opposite sides are equal in length, and specifically AB is equal in length to DC and DC is equal in length to AD. So let's investigate next the interior angles of a parallelogram. So the parallelogram has 4 interior angles. Let's focus on a pink angle first. So this is the size. We're going to move it over and compare the angle with that at the opposite side, at the opposite end. So you see that the pink angles are equal in size. Now let's do the same for the blue angle. You see that they have the same size too. So opposite interior angles are equal in size. Specifically, angle ABC is equal to angle ADC, and angle BCD, the blue angle, is equal in size to angle BAD. Next property for the parallelogram is on the diagonals of this parallelogram. So the diagonals stretch from one corner to the other corner. So first, we see this diagonal is half of it is in red, and let's draw the other diagonal. So the other diagonal intersects the original red diagonal, and we see that this red length, let's duplicate it, let's make a copy, and we see that it is exactly the same. So what this shows us is that this entire red diagonal can be divided into 2 equal halves. And here, where the 2 diagonals meet, is the intersection point, and that serves as the midpoint. So likewise for the blue diagonal. So in summary, these 2 diagonals, they bisect, they cut each other into 2 equal halves. But take note, the blue diagonal is not the same length as the red diagonal. Now they may be, but in this case, in most cases, they are not of the same length. So to fill in the blanks, the diagonals bisect. They cut each other into 2 equal halves. So specifically, AO is the same length as OC, BO is the same length as OD. The next property we are going to find out is on the area of a parallelogram. So here, by default, this is what we will see. We are able to change the shape, the dimensions of this parallelogram by adjusting these white circles. This gray circle over here, for simplicity, I'll just drag it over to one corner. So our objective is to find the area of this parallelogram. But we can do so by counting these squares over here, but it is too cumbersome. So what we can do is, from the top, draw a perpendicular line down. So this perpendicular line divides this parallelogram into a triangle and a trapezium. Next, I'm going to move this triangle to the other side, and here we have a rectangle. In summary, finding the area of this original parallelogram is the same as finding the area of this rectangle. Right? So is it a coincidence that this parallelogram can be divided into 2 parts and rearranged to become a rectangle? Can it be done for any other parallelogram? So let's find out. Let's try a parallelogram that looks like this. Again, I will place the gray dot at this point, we will draw a perpendicular line down from one corner to the base of the parallelogram. We divide it into two parts, one triangle and a trapezium. We're going to slide the triangle over to the other end and form a rectangle. So it appears that in these two cases, we can form a rectangle from a parallelogram. So let's try for this particular parallelogram. Let's see what happens. So draw a perpendicular line down. We form a triangle, and instead of another trapezium, now we get another triangle. We slide the green triangle over, and we still end up with a rectangle. So based on this, we see that the area of a parallelogram is actually the area of a rectangle. And we do know that the area of a rectangle is given by the length times the breadth. Now in this particular example, we also have the length here. For a rectangle, we call this the breadth. But we need to identify where in the original parallelogram did we have the length and the breadth. So this is the length, the same length as the rectangle, so that doesn't change, and it is the same length over here. And where did this breadth of the rectangle come from? It came from this perpendicular line from one side of the rectangle, of the parallelogram. We drop it down perpendicular to the length or the base of the parallelogram. So we're going to multiply the length by the perpendicular height. Okay, so sometimes for the area of a parallelogram, instead of saying length, we call it the base. Both are fine. So let's try with some examples. Find the area of each parallelogram. So here, our parallelogram has 4 sides. 1, 2, 3, 4. We need to determine which side to use as the base or the length. So suppose we choose PQ as the base or the length, then the perpendicular height, the corresponding perpendicular height is from S down. But I do not know this perpendicular height. So choosing PQ as the base doesn't help me at all. So let's try instead to use RQ as the base. If RQ is the base, then the perpendicular height from the opposite corner, drop a perpendicular line down, and we do know that this is 9 centimeters. So it is reasonable for us to use RQ as the base. Area equals to the base, which is 6 centimeters, times the perpendicular height, 9. 54, since the length is in centimeters, units will be square centimeters. You can go ahead and cut out this triangle, place it over here, and you obtain a rectangle, where this length is also 6, and this length is 9. Next example, again a parallelogram area. We use zy that is given as the base, so x multiplied by the perpendicular height. So similar to a triangle, the perpendicular height may not fall within the parallelogram, so it may be tempting for us to find out this perpendicular height, which is fine if we were to extend this line, and here we have the perpendicular height. Okay, alternatively, we can start from this point, draw a perpendicular line down, which means we have to extend yz. In any case, we can also use w, drop a perpendicular line down to point T, because this is already given in the diagram. So the corresponding perpendicular height, where zy is the base, will be 3x plus 4. Expand them out, we get 3x squared plus 4x. So the units over here, same, square centimeters. Okay, now in exercise 2, in the figure dx and by, these are the perpendicular heights of the parallelogram. So we need to identify dx over here is the perpendicular height, where AB is the corresponding base. Now by is also a perpendicular height, but its corresponding base will be dA. So now let's place this information in the diagram. AB 6 centimeters. So I'm using blue for this particular base, and dx is 12. dx is the perpendicular height. So I'm using blue again, 12 cm. Now AD is 8. So let's change the color. AD is 8 centimeters. Right, so now we are ready to calculate part A, area of the parallelogram, using the formula. Area, base times perpendicular height. Here we see that we only have the blue color base and its corresponding perpendicular height. Using the red color as the base doesn't help because I do not know its corresponding perpendicular height of BY yet. So we only have one choice, which is to use 6 multiplied by 12 to obtain 72 square centimeters. Now that we have the area of 72 square centimeters, we can proceed with part B, which is to find the length of BY. What is so special about the length BY? This is actually the perpendicular height, where AD is the base. So in the previous set of notes, we did similar questions where we used the area, the known area of a triangle, to find the perpendicular height of the triangle, where another of the side was considered the base. So this is using the same technique. Considering that the area is also given by dA as the base multiplied by its corresponding perpendicular height of BY. This is what the question wanted. Okay, we know that this is 72 square centimeters obtained in the previous part. We're now going to substitute the value of dA as 8 times BY is 72. So BY is now going to be 9 centimeters. In exercise number 3, a parallelogram with the sides given, SR is 12. Okay, let's circle in red. It has, we have the height SM as 5. So I'm using red color to group the length and its corresponding perpendicular height. Then point N, using another color, let's try green. Point N is on the line PS produced. So we're going to produce from P to S, continue drawing the line. This green line is now PS produced. Point N is on this line, okay. PN is perpendicular to RN. So there's a 90 degrees over here. So now we have identified N as this point. Okay, what is so unique about this is that I know that if PS is considered the base of 6, then this will be the perpendicular height, the corresponding perpendicular height, if the base is PS. So now they tell us that to find the length of Rn, okay, this particular height. This is actually a similar question to the previous one, but they do not scaffold for us. They do not provide any hints. So remember that area is the base times the perpendicular height, 12 times 5, which is 60 square meters. Okay, at the same time, area, the same area, is also the base of 6 multiplied by Rn. And this has to be 60 square meters too. So Rn is now 10 meters. And we're done. In the next exercise, number 4, we've got ABCD as a parallelogram. The entire area of ABCD is 72 square centimeters. In addition, they tell us that the perimeter of ABCD is 36. So take note, perimeter 36 means we know that opposite sides of a parallelogram have the same length. So these sides have the same length. Likewise, AD and BC, they have the same length. Now they tell us that DE is 9 centimeters. D to E. Our job now is to find AB. So I'm using the same green color because DE being perpendicular to AB, means that this is going to be the perpendicular height where AB is the base. So we're going to use the area formula. Is the base AB multiplied by the perpendicular height of DE, which is 9. And all this is supposed to give us 72. So AB must be equals to 8 centimeters. Next, we are supposed to find BC. Let's change the color. Take note that since this is a parallelogram, our length of DC is also 8 centimeters. Now we're going to make use of the next piece of information. Perimeter is 36 centimeters. Therefore, to find BC, it is going to be half of 36 minus 8 minus 8. Okay, so writing all that down, perimeter equals to 8 plus 8. Okay, so because they're opposite sides of the same length, plus BC plus, now instead of writing AD, I can write it as BC again because they have the same length. And this should give us 36. So 2 of BC is equals to 36 minus 8 minus 8. So 36 minus 16 is 20. BC has to be equal to 10 centimeters. So let's put it down, 10 centimeters. So this is also 10 centimeters. Next, in part B, they are telling us that the ratio of the area of triangle DFC. Let's highlight area DFC. DFC. This area to the area of the entire parallelogram is 3 to 10. So find the ratio of FC to BC. So how we're going to go about doing that is by considering the area of a triangle as well as the area of a parallelogram. Now, the area of triangle DFC is given by area of triangle DFC, half times the base. Now we can choose, for a triangle there are many bases that we can choose, alright, but we would want to consider a base that is given in the question. In other words, over here, FC. Okay, so half times the base FC times the perpendicular height. Now if FC is the base, then it must also have a perpendicular height over here. This has to be drawn in by yourself. Okay, let's call this H times H. Right, now let's consider the area of the parallelogram. Area of ABCD. Likewise, we're going to make use of what is required in the question of BC. So if this BC is our base of the parallelogram, BC, and then we need to find its corresponding perpendicular height. So we notice that, hey, it actually shares the same perpendicular height as the triangle earlier on. Okay, so this is the base of the parallelogram. To find its corresponding perpendicular height, we go to the opposite side. We can choose point D, drop down a perpendicular line, and we notice that it is exactly H, the same H over here. So here we have two expressions, one for the area of triangle, one for the area of the parallelogram. Okay, let's consolidate this. The ratio area of triangle DFC over area of ABCD. So ratio can be expressed in a fraction. This is given to be, we found it out earlier on, half times of FC times H. In the denominator, we have BC times H. So we are happy to see this because we can divide both numerator and denominator by H. So being a common height, they have the same value. Okay. Next, we equate all this to what was given in the question, 3/10. Now, if half of FC over BC is equals to 3/10, we can now find, therefore, FC over BC. We can find this out by multiplying both sides by 2. So let us multiply by 2 over here, and we multiply by 2 over here. The reason I'm multiplying by 2 is so that 2 times half equals to 1. Therefore, leaving me with FC over BC only. And on the other side, our result will be 3 times 2 is 6, 6/10, simplified to become 3/5. So here, our ratio of FC to BC is given to be 3:5. In exercise 5, we have another parallelogram ABCD where AB is 6 centimeters. So until this point only. And the area of triangle ADE is 3/4 that of the parallelogram. Find the length of BE. Okay, we don't have much information given, but actually what is provided is already sufficient. Let's see what we can extract, what we can interpret from this question. The area of triangle ADE is 3/4 that of the parallelogram ABCD. So first, area of ADE is 3/4 area ABCD. Okay, now whether it is the triangle, let me highlight the triangle in yellow, or the parallelogram, which I will outline in red. Do you notice that they share the same perpendicular height? Okay, so let's start with the parallelogram. Suppose we select AB as the base. Then the perpendicular height will be from D, the opposite side, drop down a perpendicular line to the base of AB. And now if you consider for the triangle highlighted in yellow, if you consider AE as the base, it has the same blue perpendicular height. Let's call this H. And this is going to be crucial for us to find the length of BE. This is actually quite a similar question to exercise 4. So moving on, let us write an expression for the area of ADE, the triangle ADE. So that would be half times the base, which is AE, times the height of H. This is equal to 3/4 of the area of ABCD. So earlier on we mentioned that we want H to be the perpendicular height, meaning the base has to be AB. So AB times H. What we can do over here is that H and H, they will cancel off. By cancelling, I mean that we divide both sides by H. Okay, since it is the same, they will disappear. Now let us substitute AB with the value of 6. So this AB, we change its value to 6. Now what we have left is that half of AE is equal to 18 divided by 4. So 18 divided by 4 is 9/2. Since half of AE is 9/2, that goes to show that AE must be multiplying by 2 on both sides, 9 centimeters. The distance from A to E is 9 centimeters. From A to B is only 6. That must mean that BE is equals to 9 minus 6, which is 3 centimeters. So in this question and in the previous one, notice the common perpendicular height. Okay, this is going to be a vital technique for us to solve this type of question. Now in exercise number 6, we've got ABCD as a parallelogram, BC being 12 units, 12 centimeters, and again area of triangle ABE is 1/5 that of the parallelogram ABCD. And now our job is to find the length of BE. Similarly, we are going to identify whether these two shapes, both the triangle and the parallelogram, whether they have the same perpendicular height. Since we have BC as 12 centimeters, it is convenient for us to choose this as the base. Okay, if this is the base, then its corresponding perpendicular height, we go over to the opposite side, point A, we drop a perpendicular line down, and we have to extend this. This over here will be our perpendicular height for the parallelogram of base 12. So by doing so, we will now also determine what should our base of the triangle be. Because we want to have two shapes sharing the same perpendicular height for ease of our working later on, if this is the perpendicular height of the triangle, then BE logically should be the base. So let us now write equations. Area triangle ABE is actually 1/5 area of ABCD. So we see that the steps are similar to what was done earlier on. So area of ABE, half times of BE times the height is 1/5 area of the parallelogram, which is base of 12 times height. It is the same height. So again, since both of them share the same height, we can divide both sides by h, and effectively they disappear, leaving us with half of BE equals to 12 over 5. Therefore, BE must be 12 over 10. Sorry, 24 over 5, which is 4.8 centimeters. Okay, this is a question on what happens if we double the base of the parallelogram. So here, the base is given to be B and the height is h. What happens if I double this? Now the base is 2b. The height doesn't change. So what happens to the area? I think from this diagram, you should have a clue already. Next part of this notes is on rhombus. So a rhombus is a four-sided figure where four sides are equal in length, opposite sides are parallel to each other, opposite angles are equal, diagonals bisect each other, and one more point, the diagonals are perpendicular to each other. So if you notice, for these three properties, they're the same as a parallelogram. In other words, a rhombus is actually a parallelogram. It is a special parallelogram where the four sides are equal and the diagonals are perpendicular to each other. So here 90 degrees, 90 degrees, and 90 degrees. Okay, so question 1. Okay, there's a missing question over here. Q1 is a rhombus a parallelogram? So it is a yes or no? The answer is yes. Why? It satisfies all the properties of a parallelogram. Next, is a parallelogram a rhombus? No, the answer is no. Why? A parallelogram may not have four equal sides. So then how do we find the area of rhombus? Can we use the same formula for parallelogram? Sure we can. Of course we can. But is there a different formula that we can use? So that is what we are going to find out now. You are given that the area of a rhombus is the same as half times the length of one diagonal times the length of the other diagonal. So let me demonstrate how we can use this formula. Given that AC has a length of 16 centimeters and the length of BD is 10 centimeters, we can now write area is half times of 16 times 10. Straight away, we get the answer of 80 square centimeters. Okay. Next, rhombus number 2. Area is half of a diagonal. Now AC is one of the diagonals, so 8 dB is the other diagonal, given to be 12. So 4 times 12 gives us 48 square centimeters. Next, area is half times of the diagonal. AC is 4, dB given to be 16, so 32 square centimeters. Next, if the length of the diagonals of rhombus is A and B, then the area is half times of AB. So now that we have covered all these, are you wondering how this formula came about? So let us explore this. Here we have a rhombus. We can actually rearrange the shapes. We see this rhombus is divided into 4 triangles. Okay, we can rearrange them by symmetry. This triangle can be placed over here. Likewise, okay, let's change the color. Let's change it to green. This particular triangle can be placed over here. So our rhombus is now changed to become a rectangle. This rectangle has the same area as the original rhombus, and it is far easier to calculate the area of a rectangle. It is just the base times the height, or the length times the breadth. So the length of this rectangle, as shown over here, happens to be this diagonal. So that is how we have one of the diagonal. Next up, we have the breadth of the rectangle over here. So this breadth is actually half of this diagonal. So there we have it, half of one diagonal to give us the breadth of the rectangle multiplied by the other diagonal, which is the length of the rectangle. This is how we derive the formula.